Okay, we got some smart cookies in here. You've never heard the term smart cookie?
I know, but like, what kind of cookie would they do?
Okay. The word equidistant. Let's break it apart. Oh, what did you say, Drew? An equal amount of distance. I really like that. Let's go ahead and rewrite that. Equal amount of distance.
Like AB has the same distance as.
So how about this?
Exactly what it says.
A and B are equidistant from B. A and C are equidistant from B. They both have the same distance to B, equal distance.
Wouldn't B be the midpoint?
I would not say that that's a midpoint because it's not a straight line.
Does it have like special name? Or is it-
No, it's B.
I feel like there's already like.
No,
Zeros? Are we gonna do zeros?
Yes.
I guess.
Colton. The word equidistant is going to come up today, tomorrow, and the next day, or whichever days we're here, okay? So here's the deal. We're gonna talk about two special things in our triangles today. The first one is called a perpendicular bisector. So let's break that apart. Perpendicular. What does that mean? Okay, so we have perpendicular. So we have that right angle, okay? And bisector. Splits it in half. So a perpendicular bisector is cutting through a segment at its midpoint, making a 90-degree angle. Okay, so look at this picture right here. Okay, I'm gonna highlight this in purple. This is our perpendicular bisector because it's at a 90-degree angle and it's going through the midpoint of AB. Okay, and what this is saying, this theorem, okay, if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment, okay? So just for effect here, let me do this. Okay, it's not a triangle right now, okay? So what's happening is I can pick a point like C, and since C is a point on the perpendicular bisector, it is equidistant from the endpoints. So I can say that this distance CA is the same as this distance CB. Any point on the perpendicular bisector is going to be equidistant, same distance from the endpoints that's intersecting. Okay, let me go ahead and just draw another picture so you understand what I'm saying here. Okay, you do not have to draw this. This is a perpendicular bisector. Do you agree? KH. Those are my initials. Okay. I can pick any point on the perpendicular bisector. And any point is going to be equidistant from my endpoints. So like these two segments are the same. These two segments are the same, etc., etc. Anytime I draw a point on this perpendicular bisector, that segment is going to be equidistant from the endpoints. Okay, now, it's a lot of crazy going on in that picture. Okay, we're just gonna focus on one triangle at a time. Okay, so this is what I want you to draw in your little notes section right here. Okay, I want you to draw a line. Okay, so here's a perpendicular bisector. I'm trying to keep it talking while I have. You don't even have your notes out. You can write them on the back of that code sheet. Okay, somebody whispered what they thought X was. Cohen? Not a very good whisper, is that what I'm hearing? Cohen, what's X? Why? Why? Okay, this point right here is on the perpendicular bisector, so it's equidistant from the endpoints. Let's call it. Okay. Okay, so this is our second example that I'm wanting you to draw. I'm not sure. Okay. Tyler thinks he has it figured out. Okay, Jack, what do you think we need to do first? What's the equation? I think that's a 3x minus 8. Okay, so we know that these two sides are going to be equal, right? Okay, so what's x? 8. Which means, okay, so dB 16. You act like this is nothing. Okay. Good golly, you all right there? Just knocking over waters. Okay, so now we also have the converse. What does converse mean? If we have if P then Q, what's the converse? if Q then P, we're gonna read it backwards. So if a point is equidistant from the endpoints, then it's on the perpendicular bisector. Okay, so we know that this point is equidistant from A and B, which means, okay, we know that it's going to be on the perpendicular bisector. Okay, so basically, we have an isosceles triangle, right? And if we have this piece here, like this, we know it's a perpendicular bisector. Okay, so this is the example I want you to write down. You can tell me what PR is. Excellent. I thought you raised your hand. Okay, so I don't know why anybody was laughing. 5 is okay. I mean, it's not right, but it's okay.
Everybody knows what you meant.
Okay, what is 5?
I mean,
This cute little piece right here. So together, it makes 10. Okay, we don't laugh at each other.
sorry, Bart.
Okay, so I just want to show you that we focused